Right, this lesson is about the fourth type of triangle center that we're going to learn about. It's also the last type, and it's called an orthocenter. Now, the orthocenter of a triangle is the intersection of the altitudes of the triangle. And what that means, when you hear the word altitude, that really means height. So altitude equals height. So when we look at this triangle here, triangle ABC, if we wanted to draw in the height of it, we would just draw a segment from C all the way down to segment AB, and it would be perpendicular to the base there, and we now have this height, or what we're going to call an altitude. But you're always used to looking at triangles that are sitting flat like this. If this triangle were sitting on this side, so if this were the base, it would also have a perpendicular height. We're going to put that on there. And if it were sitting on this side, it would also have a height from this base up, which would be right there. And all of those are perpendicular. So you can see the little right angle marks. These are all 90-degree angles. And if you just look at the bottom here, AB, and we have this height right here, CR or RC, and it seems pretty basic. And all of the altitudes intersect in a point right here called the orthocenter. So basically what you need to get out of this is that the orthocenter is the intersection of the altitudes of a triangle. Now, this is a very basic picture. This is the kind you're used to looking at, where there's a triangle sitting flat on the ground, and we have a height right here. I'm going to change this triangle up a little bit, so I want you to look at angle A right here. Right now, it's a nice, acute angle. It's 65 degrees right here, and I'm going to change this up a little. So watch what happens to my heights. You see my height right here. It's not straight up and down anymore like you're used to, but it is still perpendicular to the base. But you notice that these two are starting to get closer and closer together. And as they get closer and closer together, this angle A is getting closer and closer to 90 degrees until I get all the way down to 90 degrees. And then they just kind of disappear. You can see this segment CR. As this becomes a right angle, and this side over here is just the height. And if it were sitting on this base, this side would be the height. And if it were sitting on this base, this side would be the height. So that's kind of interesting how the sides become the height when you get to a right triangle. Now, if I make it a right triangle with the right angle at the top like that, see how this height is, this is exactly the kind of picture you're used to seeing. So what you have to do is be able to take these pictures that you're not that familiar with, so when you start seeing pictures like this, and just turn them in your mind to where the bottom is flat on the ground, and you have this height that you're looking at. It'll help you visualize what's going on. Now, what do you think is going to happen as I start to get an obtuse angle? So angle B is getting closer and closer to 90. Now it is 90. Nice right triangle. And now I'm going to make it obtuse, so I'm going to keep pushing in. You see, my orthocenter comes outside of the triangle. So the point that all of the heights intersect is outside of the triangle. And if you look at this side right here, A to B, pretend this is the bottom. If this is the bottom, does it make sense to you? I'm going to redraw it right here, but I'm going to draw it AB up to C like this. So this is A, B, C. Does it make sense to you that AB across the bottom, to find the height of this thing, AB would have to be extended out to find out how tall it is, right? Because this down here is the base, and this is the height. And that's what this is right here. That's the height, or the altitude. So anyways, that's what an orthocenter is. It is the intersection of the altitudes. You're not going to have to do anything really complicated with this. This is one of the ones where the picture can get really complicated really fast. So you're not going to have to do much with the pictures, except that you're going to have to find an orthocenter. So what I'm going to do now is a quick example, and I'll try to make it as quick as I can, of how to find the orthocenter of a triangle when you're given the vertices. And this is what you're going to have to do on your homework and on the test. So here's my triangle. I've already got all my vertices. I've already got my triangle drawn. What it's asking me to do is find the orthocenter. So I need to find the intersection of all the heights. So I have this base JL. Well, I know the height for that is going to be vertical, a vertical line, because I have a horizontal base. So this is going to be the height right here. And I'm very confident that that's the height. So I have 90 degrees. Here's one height. Now I need to find the orthocenter. So I need to find where all of these heights intersect. So I need to look at this piece, and I need to come up with a line segment that's perpendicular to it, because height is perpendicular, and it has to pass through this point J. So what I need, and this is where it's going to get a little difficult, what I need is to know where this goes. I don't know where it should go to. We should go to here, maybe we should go to here, maybe we should go here, I'm not sure. So before I just stick a point on there, I'm going to have to figure out where it needs to go. So this point J is -4, 2. So that's an x1 and a y1. And if I could find the equation using point slope form, if I could find the equation of a line that goes through point J and is perpendicular to KL, well then I would know exactly which line to put, and I could graph it on here. So I'm going to try to figure this out. I'll have my equation, y minus y1 equals m times x minus x1. And I already know the y1 is 2, the x1 is -4, so I really just need the m. So I need to know the slope of this line that's perpendicular to KL. Well, if I wanted to know the slope KL, I use the slope formula, which is y2 minus y1 over x2 minus x1. So for KL, I have x1, y1, x2, y2. I'm going to plug those numbers in. I'm going to do 2 minus 6 over 2 minus -2, which is -4 over 4, which is -1. So my slope of KL is -1, which you could have figured out yourself if you just would have gone down 1 over 1, down 1 over 1, down 1 over 1, like that. So the slope is -1 over 1. But let's assume you didn't do it that way and you worked it all out, and now you know how to do it. So the slope of KL is -1. The slope that's perpendicular to KL is not -1. Remember, to do perpendicular slope, I take my slope of my segment, KL, and I flip and switch. So I'm going to turn it into positive 1 over 1. So the slope that's perpendicular to KL is 1. So I come over here, y minus 2 equals 1 times x minus -4, because x1 is -4. So I get y minus 2 equals 1 times x plus 4. So y minus 2 equals x plus 4. So y equals x plus 6. That's the equation of the line that goes through point J and is perpendicular to KL. So how do I graph it? Well, this is my y-intercept. So I'm going to go 1, 2, 3, 4, 5, 6. Put a point right there. And then I'm going to connect point J with my y-intercept there. So now you can see I have a very nice intersection right here. And the other altitude, if I went from this side, would also intersect with this point. I'm going to show you a little faster way to do that one instead of doing all this stuff. If you have the graph, well, all you have to do is look at your line, so or my line segment, JK. And the slope here I see goes up 2 over 1, up 2 over 1. So the slope of JK is up 2 over 1. So the slope of a line that's perpendicular to JK is down 1 over 2, because I flip this over, switch it from positive to negative. I need it to go through this point, so I'm going to start at this point, and I'm going to go down 1 over 2, put a dot right there. I'm going to make my line that goes through this point and this point, and look, like a little Christmas miracle, it also goes through this point. So my circumcenter here is 1, 2, negative 2, comma, 1, 2, 3, 4. Negative 2, 4. So a couple different ways to do it. You can do it the algebra way if you don't have a nice picture. But if you do have a nice picture, my advice to you would be to work smarter, not harder.